When we look at our solar system, what do we see? We see design and order, not random chance processes. Join us for a tour of some of the moons and smaller bodies within our solar system using stunning photographs from NASA and other sources. Along the way, we'll observe that there is evidence that these objects did not form by natural processes billions of years ago. Instead, they appear to be young and created quite recently. Coming up on today's edition of Origins, Our Created Solar System Part 2 with Spike Psarris. Hello, welcome to Origins. I'm Ray Heiple. We have an interesting show for you today. Our guest, Spike Psarris, has a degree in electrical engineering and has done graduate work in physics. He was formerly an engineer in the United States military space program. He is an author and popular speaker on astronomy and related topics. Spike founded Creation Astronomy and has produced many fascinating videos defending a young Earth view as related in the Bible. Welcome to the program, Spike.
Thank you, Ray. Glad to be here.
So we're looking at Our Created Solar System Part 2.
Yes.
On the previous program, Part 1, and which I hope our viewers saw, we looked at some of the problems with the secular models for the planets in the solar system, didn't we? So what are you going to show us today?
Well, viewers don't need to have seen Part 1 to understand this material, so I'll say that up front. We're going to cover some things today that we didn't have the chance to talk about in the previous episode.
Great. Well, let's go ahead and get started then.
So, of course, we're coming at this from the perspective of the biblical creation. The Bible says that in the beginning God created the heavens and the earth. Secular scientists who don't accept creation believe that the solar system formed from a giant swirling cloud of gas that formed dust and pebbles and rocks and asteroids and planets. And last time we went through each planet in the solar system and showed how each one uniquely contradicts that model in a different way. What we didn't have the chance to talk about then is a lot of the smaller bodies in the solar system, some of the moons and some of the other objects we see. And these too are interesting in a lot of what they can tell us about origins. So let's start with Jupiter. Jupiter has many moons, of course. The most famous are the 4 Galilean moons. There's Io, Europa, Ganymede, and Callisto. I'd like to focus talking about Io. So I'm going to go up to the screen if I could, and we'll talk about some of this. So Io is a really interesting moon. It's actually the most volcanically active body in the solar system. You see a lot of these large blotches. Those are all volcanic structures. Io is really dramatic in a lot of what it does. It has eruptions that sometimes blast material into space 180 miles. Very dramatic. It also produces huge amounts of material from these volcanic structures. We saw one eruption that produced 31 cubic kilometers of material in just 100 days. You see this sequence of photographs here, this blotch, how it got bigger and bigger. Some of the eruptions we've seen have been the sizes of United States, states in the US, such as Arizona, Nevada, very large eruptions of material. Now, this is interesting because how would a body still be this active after 4.5 billion years? Where's the energy coming from to do this? Well, the answer is it really looks rather young because the energy to produce this geological activity wouldn't last for billions of years since its formation if it actually had come from the cloud of gas like we talked about. So what is the source of all this heat to drive all of this geological activity is the first issue. Secular scientists say that Io is caught kind of in a gravitational tug of war between Jupiter on one side and some of the other moons of Jupiter on the other. And so that's squeezing and flexing Io and imparting geological energy into it. Now that's true, but that only accounts for a small amount of the heat necessary to drive the activity that we're seeing. So a logical conclusion is that the rest of the heat is left as primordial heat, left over from its formation. But that, again, was supposed to be billions of years ago, which means the heat would have been gone a long time ago. So this is an argument for youth of Io, the fact that a lot of this heat appears to be primordial, left over from its formation. So if it was created recently, this isn't a problem. It's still cooling off from its recent creation. If it's billions of years old, though, that's an issue. Another issue is that when you measure the amount of material that comes out of some of these volcanoes, if Io were 4.5 billion years old, it would have recycled itself through its own volcanoes over 30 times.
Oh, that's fascinating. So 30 times the planet just
The
inside
moon, yes.
out, or the moon, yeah, over and over again.
Right.
Wow, that goes to show you that that can't be that old.
It doesn't seem to make sense to say that it is. Another issue is that with all this transport of material, well, with all this material moving around, some of these lavas are less dense than others. So over time, the less dense material should have risen, the denser, heavier material should have sank. And so Io should have formed a low density crust by it now, were it actually billions of years old. But it hasn't done that yet. So again, this is an argument for Io looking a lot younger than what is commonly said.
Do they have any answers that somehow save the older origin, or do they try to say it's young?
There's a lot of people writing about this, but a lot of these are still unsolved challenges for them. So another moon of Jupiter is Ganymede. It's actually the largest moon of Jupiter. Interesting thing about Ganymede is that it has a magnetic field. And this is a challenge for people who want to believe in a long age for it, because magnetism shouldn't last on small bodies for long periods of time. There's a couple of possible reasons that an object could have a magnetic field. One of them is remnant or residual magnetism left over from its formation, but that can't last very long. The only way to have a magnetic field over long periods of time is what's called a dynamo, and without going into details about that, Ganymede is too small to have one. So if it can't have a dynamo, then it shouldn't have a magnetic field anymore after billions of years. The fact that it does still have one would indicate it hasn't been billions of years since it was formed. There's other moons about Jupiter we could talk about, but let's move on and talk about Saturn briefly. Saturn has some really interesting moons. We'll talk about a few of those. This is Enceladus, very pretty little moon, actually the brightest object in the solar system. It reflects more sunlight back into space than anything else does. And Enceladus is intriguing. Some of our first photographs of it were kind of provocative. These are Saturn's rings viewed almost edge on here. You can see Enceladus, and right below the moon here, there's this little smudge. And in our first photographs, we were thinking, what exactly is going on here? Close-up reveals that Enceladus has fountains and geysers of water and ice coming out of the region by its south pole, shooting out at 800 miles per hour.
Liquid water that far from the sun.
Yes. So what is powering this? This requires a tremendous amount of energy, as you can imagine. Well, the usual explanation is Enceladus is caught in tidal flexing, squeezing and flexing from gravity, as I mentioned with Io. And again, with Enceladus, that doesn't work very well. It's supposed to be far too old to be geologically active like this. You can see in this colorized picture how far into space some of this material is shooting. We've actually noticed, by the way, some of Enceladus's neighboring moons are brighter than they otherwise would be because Enceladus is spray painting them with ice and snow. So again, what's the source of energy for this? This type of geological activity has to be powered by something. Tidal flexing, as we talked about, can only account for a small percentage of what's going on here. And also that explanation doesn't match the distribution of temperatures that we see if that were actually going on. Enceladus looks like it's still cooling off from its formation. If that formation were billions of years ago, it shouldn't be doing this anymore. So if it's a recent creation, this isn't a problem. It matches what we see. If it's billions of years old, that is an issue.
So in example after example, the recent origin theory lines up with the evidence, and the
Yes.
billions of years theory just doesn't.
True. And that's also true for Titan, which is Saturn's largest moon. You see this photograph looks fuzzy. That's because Titan actually has an atmosphere. Now from Earth, we can't see through the atmosphere because it's opaque, but we can watch sunlight reflecting off of it and glean some insights about it. Turns out Titan has a lot of methane in its atmosphere. Now that's interesting because methane breaks down from sunlight, and then the products from that breakdown reform into ethane and other chemicals. And it turns out the methane can't last very long in the atmosphere before it's all gone. So if it were actually billions of years old, that methane should have been gone over 4 billion years ago, but it's still there. So secular scientists concluded there must be a source of methane on the surface to keep replenishing the atmosphere. And also, if this breakdown process and reforming into ethane has been going on for billions of years, there also should be a lot of ethane built up as a result of billions of years of methane converting into it. So as this scientist said, he predicted that we would find Titan is covered by a global ocean of ethane, and probably some methane as well, with an average depth of up to several kilometers. Now this prediction is based explicitly on the billions of years. If Titan's billions of years old and it's been doing this process billions of years, this is what we should see, global ocean of liquid hydrocarbons. What did we actually see? Well, the Cassini mission included a lander that was emitted from the spacecraft, as this animation shows, broke off and made its own independent journey down to Titan, actually went through the atmosphere and parachuted down to land on the surface. What did we find when it got there? This is a photograph sent back by the lander. There's no global ocean of methane and ethane. It's a dry surface. Now, there were a few lakes, mostly in the polar regions, but not the 2-kilometer deep global ocean that was predicted. Now, if Titan is only thousands of years old, this makes perfect sense. There hasn't been enough time for methane to break down in the atmosphere. There hasn't been enough time for ethane to build up on the surface. Yet, this is what we see. And the last thing I'll mention with Saturn, it has two little moons that are kind of fun, Janus and Epimetheus. These are called the dancing moons of Saturn. Now, these are two different objects orbiting next to each other. Over time, as kind of shown in this the simulation here, these moons actually swap orbits. It's probably hard to see here on the screen, but as they orbit, the one on the outside is moving a bit slower on the inside. They actually cross and assume the other's orbit, and then on the next one around, they interact again. So these two moons are swapping orbits every time they meet. Now, how finely tuned do you have to make this system in order to have this happen? Is this the product of random processes, or is this kind of a fun little thing that our Creator left for us to find? I think it's the latter. Moving on, we come to Pluto. Now, Pluto, of course, is a big controversy about whether or not we should call it a planet or whatever, but I like focusing just on the object itself. There's a lot of fun stuff here with Pluto. Now, we've known for a while that Pluto had a large moon named Charon. Pluto itself, incidentally, wasn't discovered until 1930 and was still mysterious really until the New Horizons mission arrived in 2015 and did a flyby. And that flyby revealed all kinds of fun stuff. Turns out, here's Pluto, here's Charon orbiting it. Turns out there's other moons here as well that we'll talk about in a moment. But Pluto itself was not at all what secular scientists expected. This is a little tiny object way out on the edge of the solar system, old, cold, and dead, supposed to be by now. Not what we found. People who believe in billions of years were really surprised. First of all, you see this large area here. Notice how smooth this area is compared to the more rugged regions over here. There's large areas of smooth, craterless terrain on Pluto. Now, what can we glean from that? Well, the fact that it's craterless tells us that it's a very young surface, because there hasn't been enough time for craters to accumulate there. There aren't any in large areas of this. As this particular scientist said, this is one of the youngest surfaces we've ever seen in the solar system. Totally unexpected for this little tiny body way out there. Now, you notice some of this area is smooth, and then there's rugged regions, and there's also some craters that are filled in. So it seems that the surface did have craters, and then something has happened more recently that has flowed into those craters and filled them in. How did this work, though? Pluto's apparently geologically active, and the fact that this terrain is so young means perhaps it's still geologically active even today. As a scientist said, this could be only a week old for all we know. It looks that young and fresh. Now, a tiny body like this presents a real challenge because there's only a few possible sources of heat for geological activity. There's really just these three. There's radioactive decay, which produces heat, of course, tidal flexing, like we talked about, squeezing and flexing, and primordial heat. But Pluto, interestingly, doesn't have two of those three options available to it. We know that radioactivity is not an option because radioactive elements are very heavy and dense. Like if you had a chunk of uranium in your hand, not that that's a good idea, but it's very heavy. So if Pluto had a lot of radioactive material, it too would be a dense body, but it's not. Its density is fairly low. So we know it doesn't have a lot of radioactive elements, therefore not a lot of radioactive decay, therefore not a lot of heat from decay. We also know tidal flexing isn't an option. It's stable in its mutual orbit with Charon, so there's no flexing going on either. The only source for heat to drive the geological activity, therefore, is primordial heat, which would be left over from its formation. But Pluto is a small body, and small bodies cool off quickly compared to large bodies. In fact, I believe I have a slide here. Yes, you see how this is Pluto and Charon compared to the Earth. Small bodies cool off quickly. Therefore, if Pluto were billions of years old, it should have cooled off long ago. It apparently hasn't done that yet, which is why secular scientists make comments like this one. Finding that Pluto is geologically active after 4.5 billion years, there's not big enough typeface to write that in. It's unbelievable.
So they admit that there can't be the radioactive heat, it can't be the pressure from the other
tidal
planets,
flexing.
the tidal. And the only thing that we know of that's left is it's got to be really young, and the heat from the forming is still warming the planet.
They actually aren't saying it's young. That's kind of an interesting aspect of this. They admit that the heat is a problem, that it's unexplainable. Now, from our perspective, we would say, well, it's still cooling off from its formation. If Pluto's only thousands of years old, that makes perfect sense. Billions of years old doesn't make sense. But even given what the evidence seems to be saying, they're unwilling to grapple with the implications of this. As this author said, every time we have looked at a body that has experienced tidal heating, such as Io, Europa, which we didn't have a chance to talk about, and Enceladus, we find that the body has been more active or is putting out 10 to 100 times the amount of heat predicted by models. We've seen this over and over again. These bodies have a lot more heat than they should have after billions of years. But what are they questioning as a result of this? It continues. Enceladus taught us that our models of tidal heating for icy bodies were not right. And I think the Pluto-Charon system could be telling us something similar. So are they questioning the billions of years? No. They're questioning their understanding of heat. They're questioning basic things like hot bodies cool off. That's on the table to be questioned before the billions of years are.
Kind of makes you scratch your head, doesn't it? We have another really interesting system of weird moons to look at right after these messages, so stay with us.
We hope you're enjoying Origins TV. It all started at Cornerstone Television in Pittsburgh, Pennsylvania. We've been producing new episodes for over 37 years now. We praise God for the success of the program and are excited to introduce you to Origins and to us. If you're interested in watching more episodes of Origins, you can find them on our YouTube page. Simply go to YouTube and search Cornerstone Television Network. Click the like and subscribe buttons, then you'll find the best episodes of Origins in our playlist. You can also visit our website at ctvn.org/origins. One more way you can stay connected with us is to subscribe to our free monthly Hope Today newsletter, which you can do from our website. And if you have any questions, call us here at Cornerstone Television at 888-665-4483. We'd love to connect with you. Thank you for watching.
Welcome back to Origins. We're talking to Spike Psarris, who's been sharing about our created solar system, part 2. Spike, we talked about some weird moons that are out there. Can you tell us what that means?
We mentioned that Pluto has a system of moons, which was actually unknown until quite recently. We did know that Pluto has a large moon named Charon, but some of these smaller ones, as I mentioned, were unknown, and some of these are actually pretty strange. Charon itself is interesting. In the previous segment before the break, we talked about how Pluto has evidence of recent heating and geological activity. Charon has this as well, albeit on a bit lesser scale. So again, this doesn't match the billions of years time frame for these objects, that they're still geologically active today, despite having no apparent source of heat to do so, other than that left over from recent creation. The other moons have this really interesting system here. As you see, they have near perfect circular orbits, but they also have interesting rotation patterns, as shown in this graphic here. Notice too, Pluto and Charon are orbiting a common center of mass. You see that Pluto is wobbling as it goes around, as opposed to staying still. Now, this little system was unexpected by secular modelers, because how did this get there if these objects form from that gas cloud and by random processes? Some people have proposed a collision as the explanation for these things. Other people have pointed out, though, that a collision, A, wouldn't have produced these near perfect circular orbits, and B, would also have produced a lot of rubble that presumably would be orbiting Pluto and Charon as well, but we don't see any of that. So it has this neat little system of moons that was totally unexpected and very difficult to explain, other than just saying that's how it was created. More we could say about that, but let's move on to comets and talk about these briefly. So a lot of us have seen comets in the sky. Sometimes there's really spectacular ones, sometimes they don't look as nice depending on their orbit in relation to us as they approach the sun. But what are these objects? I mean, they look roughly the same as they appear in the sky to us. Some are more spectacular than others, as I said. A comet is basically a dirty snowball in space. The graphic I'm showing here is the Wild-2 comet, which is about 3 miles across, so that gives you a rough idea of the size. Some are bigger, some are smaller, but these are roughly the size that they are. So for most of its orbit, a comet isn't very interesting because they're small, they're dark, so they don't reflect much light from the sun, we can't see them. But then as they approach the sun, they begin to heat up and their ices sublimate into gas. The gas comes out as jets, and then those jets form the beautiful tails that we see often from Earth. But that means that every time a comet approaches the sun, it's losing a significant amount of material, especially for those that approach the sun more closely.
So that tail is part of the comet.
It used to be. Now it's material that's being blown away, basically.
So it should be getting smaller as it
And it does. And in fact, when a comet approaches the sun too many times, it'll eventually break up into fragments and pieces, as we've seen happen several times, as you see in this picture here. Now this implies, therefore, there's a maximum lifespan for a comet. Now, different comets have different orbits. Some approach the sun more frequently than others. The group that approaches the sun the most frequently is called short period comets. And it turns out that they, as a result of this process we're talking about, have very limited lifespans. They're either going to be broken up into fragments and then dissipate, or they'll crash into something like Jupiter or the sun, or they might interact gravitationally with something and get flung out of the solar system completely. But regardless of which of those three fates it suffers, that comet is gone. It dies, so to speak. And you can calculate with short period comets specifically, they can only last less than 100,000 years. Most of them actually for much shorter time than that. 10,000-ish years is a maximum lifespan for most. So this testifies to a recent creation. The secular model, even in their paradigm with the cloud of gas and dust and all the rest of it, in their model, comets could only have formed at the very beginning of the solar system. So if the solar system were billions of years old, short period comets shouldn't be here anymore because they're not making any new ones, so to speak.
And when we say 100,000 years, we're not saying they are that old, but looking at their mass and how they lose it, that's all the older they could be.
Correct.
Which is very young in secular terms.
That's the maximum, not an absolute.
Yeah.
And the same reasoning applies when we look at other cometary type bodies in the solar system. For example, we're discovering that there are some objects in the asteroid belt that therefore you would think were asteroids are turning out to be icy bodies and basically comets, and they're behaving like comets. Some of them have been seen disintegrating quite recently, as we see in this image here. Now, the asteroid belt is fairly close to the sun. But these bodies don't have the opportunity to go way out from the sun and stay cool for a while and then come back in. They're at the same distance. And therefore, if these objects were actually billions of years old, you would think that the ones susceptible to this process would have burned out long, long ago. Nevertheless, though, we're discovering there are quite a few of these, what are now called active asteroids, which are behaving like comets and are, for all intents and purposes, comets. Now, the way they're breaking up, it turns out, without going into details, sunlight is hitting them, causing a spin, and then they're disintegrating as a result of that. These are apparently very delicate objects if mere sunshine can break them up over time. That being the case, how can they have lasted in the asteroid belt for billions of years? This doesn't make sense. It makes more reasonable sense to see that these objects, like this one here, was thought to be an asteroid until it spouted several tails, are actually quite young and haven't been there that long, and that's why they haven't broken up yet. So the idea that these objects have been there for billions of years for these and other reasons doesn't make much sense. From a recent creation, if these objects are only 6,000 years old, what we see makes perfect sense. It's fine.
And that's really interesting because that, like you said, that asteroid belt, they're there. They're part of that stable belt, and where did they come from if they're so old because they couldn't have been there that long or they'd have been gone?
Correct. So all of these objects we talked about, not only comets, but also the moons, Pluto, its moons, these are all testimonies, if you will, to a recent creation. So just to recap, looking at the smaller bodies of the solar system, they have a lot to tell us about origins as well, as all the larger bodies did. And one of the fun things I think about this too is that these objects have been unknown to mankind for most of our history. I mean, Pluto's been there the whole time for 6,000 years since creation. We didn't even know it existed until 1930, and we didn't have good data about it until 2015. So it's been there the whole time, quietly waiting for us, if you will. And I think it's interesting that as mankind has developed this better technology to go do this exploration and learn more about creation, that the Lord has placed all these fun little things there for us to find.
It seems like more and more, as they find these things, they're finding more evidence that the universe, the solar system, really is very, very young.
Yes. As the Bible says, the heavens declare the glory of God. And the more we explore, the more we're finding this is true. I think it's a great privilege and a wonder, really, to be able to do this and appreciate more of what the Lord has done through discovering these things he has made. Very fun topic, and much more that could be said. But in our overview here, I hope this has been interesting to people and they can get a glimpse of what this topic holds for us.
Spike, I really want to thank you for being on the program. Part 2, we finished it. We talked about Pluto and we got through it, so thank you.
Thank you for having me.
And thank you for joining us. On today's program, we examined the status of certain bodies in the solar system in the light of the current secular understanding of billions of years old. We saw that the evidence supports a very young origin for each of these bodies, and yet the secularist will not even consider the implications. For as the Bible says, knowing God, they suppress the truth in unrighteousness. But we know what the Bible says is true, and the proof really is all around you. If you enjoy Origins, we sure could use your help to keep this Creation television program on the air. Your support, both prayerfully and financially, make a big impact. So let's work together to reveal how awesome our Creator truly is. And we'll see you next time right here on Origins.
Thank you for watching this edition of Origins. For a DVD of this series, you can order online or send a $12 donation to cover shipping and handling and write to Origins Program number 2313, Cornerstone Network, Wall, Pennsylvania, 15148.
This presentation was made possible by the faithful prayers and financial support of you, our Cornerstone family.